In this lesson, we are going to find the probability of sequential events. So this is more than one event occurring. So again, we're looking for and events. So we're saying first something happens and then something else happens. And the way that we find that probability is to multiply those probabilities together. But be very careful on whether or not they are dependent or independent. So let's take a look. If I'm flipping a coin 3 times, the probability that I'll get heads each time, which means the probability that I'll get heads the first time, which is 1/2. Again, theoretical probability. The probability that I'll get heads the second time, which is 1/2. And the probability that I'll get heads the third time, which is 1/2. So 1/2 times 1/2 times 1/2, which is 1/8, would be my probability. These are called independent events because flipping a heads the first time does not change the chances of me flipping a heads the second time or the third time. Again, here's a question. A student takes a 20-question multiple choice test and gets a perfect score of 100% with no work shown, and the student claims that she guessed correctly on all of the questions. So what's the probability of that actually happening? If each of those 20 questions has 4 possible answers, what we're saying is the first question I have a 1 out of 4 possibility of getting it right. The second question, a 1 out of 4, etc. And so essentially I've got 1/4 to the 20th power. So the chances of this student having no knowledge and really just randomly guessing is 1 over 4 to the 20th. 1 over 4 to the 20th is a ginormous number. So 1 over all of that. Now, just as a frame of reference, the probability that you'll get struck by lightning is 1 over 750,000. So do you believe her or do you not believe her? Because I'm going to say no. Now, this is a different question than what we just did, because what we just did were independent events, and these are called dependent events. They are dependent because I have a bag of marbles and I'm going to take out the black marble, which means the second time I choose a marble, there are no longer the same number of marbles in the bag. So we're going to do exactly what we did before, where we're multiplying the probability of A and B would give me the probability of A times the probability of B. Now, instead, we're going to say the probability of A times the probability of B given A. So we're saying, assume A happened, what's left? So in this case, the probability of black and then a blue, again, that's 2 different events occurring. So the probability of black is 4 out of 10 total marbles. The probability of blue, you might say, is 3 out of 10. But because in this instance I took out that 1 black marble, there are now 9 marbles left. 3 are black, 3 are blue, and 3 are red. So 3 blue out of 9 marbles that are left over. Then, of course, I can multiply and reduce, or reduce then multiply. You know, I like to reduce first, so I'm going to call 1 and 3 and divide that by 2 and divide that by 2, and I end up with 2 times 1 and 5 times 3, so 2/15. That's the probability. Again, because it was dependent, meaning we had to say, assuming that that occurred, that the first time I did actually take out 1 black marble, there were now 9 left. Looking at this one, this is also a dependent event because I'm not putting that card back in the deck. So the first time, 2 aces is what I'm doing, but it's actually 2 different events. So the first event, there are 4 aces out of 52 cards. So the probability of ace and ace. There are 4 aces out of 52 cards multiplied by, now there are 51 cards, but in addition, there are only 3 aces left because I took 1 out the first time. So I've got 4 52nds times 3 51st. Again, I'm going to do some reduction, so I'm going to divide by 4 and divide by 4. I'm going to divide by 3 and divide by 3, and then I'm going to multiply 1 over 221. So that's the probability. Here is a question for you to try on your own. So try this question, then press play to check your work. Suppose that you will have 9 children. You better get started. What's the probability that they will all be boys? Well, what's the probability of having a boy? 1/2, theoretically. If there are 9 of them, that's 1/2 to the 9th, which is basically 1/2 times itself 9 times. And multiplying that out, I get 1 to the 9th over 2 to the 9th, which is 1 over 512. That as a decimal, the chances are very, very low. And yet the reason I chose this question is because I don't have 9 children, but I do have 9 nephews, all boys. So the possibility or the probability of that happening is less than 1%.